In my previous video, I discussed exoplanets discovered in 2024, including Barnard star B, a small rocky exoplanet orbiting the nearby red dwarf Barnard star. The study that found it also detected 3 other promising exoplanet candidates. In March 2025, a new paper was published that confirmed these 3 other signals as bona fide exoplanets, as well as updated parameters on Barnard star B. These exoplanets were confirmed with radial velocity measurements by 2 telescopes, the Gemini telescope in Hawaii and the Very Large Telescope in Chile. This discovery of 4 small planets around Barnard star is exciting due to the long history of attempts to detect planets around this particular star. In the 1960s and early 70s, Peter van Camp, a Dutch astronomer, claimed that he had detected a Jupiter-sized exoplanet around Barnard star using astrometry, but this was refuted in 1973 with a follow-up study by another observatory. In 2018, an international team of astronomers put forward a super-Earth candidate with a minimum mass of 3.2 Earth masses, orbiting at a distance where the system's snow line would be, making it a cold planet. However, this was also refuted in 2021, when it was determined that the radial velocity signal actually came from Barnard star itself. But now, in 2025, we finally have several confirmed exoplanets orbiting Barnard star. We will go through each one in just a moment, but first, let me tell you about how we label exoplanets. For exoplanetary systems, we label exoplanets as B, C, D, etc. in order of discovery, not distance to the parent star. We often have transiting multiplanetary systems with the order of discovery and the order of distance matching each other because the innermost planet has a shorter orbital period and is thus more likely to have had multiple transits observed first. TRAPPIST-1 is an example of this. In the case of Barnard star, the innermost planet is Barnard star D, which has an orbital period of 2.34 days and a minimum mass of 0.263 Earth masses. It's the closest planet to Barnard star, but it was discovered third. Barnard star B was discovered first in 2024 and it was discussed in a previous video. It's the second planet from Barnard star and it has an updated minimum mass value of 0.299 Earth masses, whereas the previous estimate was 0.37. Next, Barnard star C is the third planet and has the highest minimum mass value at 0.335 Earth masses and an orbital period of 4.12 days. Planet E has the lowest minimum mass of 0.193 Earth masses and an orbital period of 6.7 days. It's the lowest mass exoplanet detected by the radial velocity method yet. The reason why these planets have a minimum mass estimate rather than a true mass is because we don't know the inclination of the planetary system. If we knew the inclination, we could use this equation to calculate the true mass. All 4 exoplanets orbit inwards of the habitable zone, so too hot for life, and the study found no evidence for a planet between 0.37 and 0.57 Earth masses within the habitable zone of Barnard star. But this doesn't rule out the possibility of there being a smaller planet in the habitable zone, for example, a planet the size of Mars. However, Barnard star has been observed to emit stellar flares, which is a barrier to habitability since stellar flares and winds are known to strip planets of their atmospheres. So even if there were a planet located within the habitable zone, the amount of ultraviolet radiation it will receive from its sun makes it unsuitable to sustain life. After 30 years of exoplanet discoveries, we have found that M-dwarfs often host small, compact systems of rocky planets, and Barnard star is another classic example of this pattern. M-dwarf stars are the most abundant type of star in the universe, and due to their small size, it's easier to detect rocky planets orbiting them. So these systems are ideal targets in the search for life, and this latest discovery encourages further searches for exoplanets in our stellar neighborhood. Thank you for watching this video. I hope you enjoyed it and learned something new today. Stay curious, and I hope to see you again soon.